Okay, today's video we're going to continue to look at polar coordinates, and in fact today what we're going to do is compare them to um, rectangular coordinates and see how we can convert between the two. All right, so we've got our point P here, and of course this would be theta, and this is going to be R. If I drop in perpendicular here, now I have X and Y all related in the same triangle. So let's take a look at what we know. We know the cosine of theta is equal to the adjacent over the hypotenuse, or X over R. So if I solve this for X, just multiplying both sides by R, X is equal to R cosine theta. I can do the same thing for the sine of theta, and the sine of theta is equal to y over r. Go ahead and multiply both sides by r there. We get y is equal to r sine theta. So x always goes with cosine, y always goes with sine. And this is pretty simple. This is all you need in order to convert polar to rectangular. And it's a pretty quick, easy conversion. You just substitute in your r and your cosine. You're going to come up with x, r and your sine of theta, and you're going to come up with y. All right, we also know the tangent of theta is equal to y over x. And this one I'm going to do differently. I'm going to take the inverse tangent of both sides. So that's going to give me that theta is equal to the inverse tan of y over x. And the fourth thing we can get from here is the Pythagorean theorem, and I know that x squared plus y squared is going to equal r squared. And if I take the square root of both sides, that gives me r is equal to the square root of x squared plus y squared. And now I'm going to be getting r and theta from x and y. And this is how I'm going to convert rectangular to polar. And when you convert rectangular to polar, you must draw the picture of this. So you got to draw this thing first in order to solve this. All right, so let's take a look at an example. We're going to convert these polar coordinates. My radius here is 2. My angle theta is 3 pi over 2, and I want to convert that to rectangular coordinates. Well, all I need to do for rectangular coordinates is solve for x, where x is equal to r cosine theta, and y, where y is equal to r sine theta. And that's all there is to it. So substituting into here, x is going to equal 2 times the cosine of 3 pi over 2. Okay, so x is equal to 2 times the cosine of 3 pi over 2, which by your unit circle gives you 0. So x is equal to 0. Doing the same thing for y, I'm going to find that y is equal to r, which is 2 times the sine of 3 pi over 2. So y is equal to 2 times the sine of 3 pi over 2, and that will be -1. So y equals a -1. So the ordered pair is 0, -1 in rectangular form, and that gives me the same point as the polar coordinates 2, 3 pi over 3 pi over 2 rather. I got another example here. I don't think you really need to see that. It's pretty straightforward. Okay, and I'll do one example here for you for converting rectangular to polar coordinates, and r is going to be greater than 0, and theta is going to be between 0 and 2 pi. It's just giving, because remember, there's infinitely many polar coordinates that will give you the same exact point. All right, so that conversion is, I'm going to find theta, and theta is equal to the inverse tan of y over x. And I need to find r, and r is equal to the square root of x squared plus y squared. and then I'll have my R and my theta. So we've got the inverse tan here of y over x, so it's going to be root 3 over a negative 1. And that looks pretty familiar from your unit circle. We need to draw this first, though. Where am I? Because there's going to be two answers for this question. And we are at negative 1, root 3, somewhere up here. So we are in the second quadrant. That's what the important part of drawing the angle, so you know exactly where you are. And that theta will be 2 pi over 3. It's a special angle. If it wasn't a special angle, I'd just use my calculator. And r then is going to equal the square root of x squared plus y squared, so that's going to equal negative 1 squared plus root 3 squared, which gives me the square root of 4, or r is equal to 2. So in polar coordinates, r theta, and that's all there is to it. That's how you convert from rectangular to polar, and then polar to rectangular. Pretty short, quick, and easy. Keep asking questions on Google Classroom, and have a great day.